Good morning, ladies and gentlemen. Happy Monday morning or afternoon, or to be entirely honest, Sunday night. As you've probably been able to figure out, I'm not there today, and I won't be there for a few days due to COVID restrictions. I'm fine. My wife is unfortunately testing positive. So what that means is that I'll be able to spend some time here at home with my dog and be recording these video lessons for you. Speaking of which, Archie, come here. Come on up. Yeah, come on up. Yeah. Here he is. As a quick present for you guys, this is the goodest boy. Archie, say hi. Yeah. So he's going to be here with us. We're going to be keeping him company for the next couple of days, and he's going to be a very happy pup. All right. But for the general way things are going to work in class, things aren't really going to change much. As of right now, I don't have any foldables for you because they're not printed out. If anything changes and I can get people to print those out so you can have them, I'll be sure to let you know. Please keep checking the in and out boxes for your periods, and you'll see if there's anything for you. For today, though, we're going to continue as we normally do. We've got these notes, and then along with the notes, you've got a quiz. The quiz will be on the Mastering platform, the platform that you get your textbook in, the platform that you all accessed at the beginning of the year. If you followed the instructions, you made an account for that has, or that uses your school email as the username and your school password as the login. If you manage to get Google to save all that for you, then you should be fine. Just go to Google, search Mastering Biology, and go on through the links there. If you have any questions, I will be open, or there will be a Zoom link open during class for you to be able to ask me any questions. But other than that, let's just start going through these notes. Please take a moment to look at this think, pair, share question, and I will continue to wrestle with my dog. All right, so how did eukaryotes evolve from prokaryotes? Please take a couple of seconds now, pause the video if you have to come up with at least two major differences between prokaryotes and eukaryotes. Things that make prokaryotes and eukaryotes different. All right, obviously, the main two that I'm hoping you remember are that prokaryotes do not have a nucleus and do not have an inner membrane system, or as we fancily put it, an endomembrane system. Other answers include the fact that prokaryotes tend to be single-celled, or eukaryotes tend to be multicellular, and that prokaryote DNA tends to be circular, while eukaryote DNA tends to be linear. All right, and so let's get into this. Eukaryotic cells evolved, to be entirely honest, from simpler prokaryotic cells. The first prokaryotes appeared approximately 3.5 billion years ago, and were the only form of life around on Earth for about 1.7 billion years. However, about 1.8 billion years ago, the first eukaryotic cells appeared. And these eukaryotic cells were different because, well, they had these membranes inside of them, which allowed for greater complexity and, honestly, isolation of metabolic materials or processes. The main thing that allows all of this to happen is this endomembrane system. If you remember back from when we were talking about cells, the endomembrane system consists of the nucleus and all of the foldy membranes on the inside of the cell that have to deal with protein production and shipping. The endomembrane system is found in every single eukaryotic cell. It's a series of internal membranes and membrane-enclosed organelles. It includes the endoplasmic reticulum, the nuclear envelope, the Golgi apparatus, lysosomes, vesicles, and other things like that, and it caps off at the plasma membrane on the outside. Give you a bit longer to write this down. Just as a refresher, the endomembrane system, we think, arose from the folding inwards of the plasma membrane of an ancestral prokaryotic cell. It folded inward, folded inward, folded inward until eventually it just kind of separated the bits that were folded inwards from the outside layer. Vesicles, if you remember, are little sacs, little baggies of membrane inside the cell. They're used to carry things from places to place. They bud off of one organelle and merge into another, helping to transfer membranes and the stuff inside the membranes from one organelle to another. So here's your infolding of the plasma membrane. Once again, this is how we think the endomembrane system kind of started. The plasma membrane folded inwards and eventually pinched off to the folded membrane on the inside of the cell, surrounding the DNA, for the most part. This brings us to the concept of endosymbiosis, which is one of my favorite concepts in all of, well, cell theory. The idea that the reason we have mitochondria and chloroplasts is because you had this eukaryotic cell that engulfed other prokaryotes, and instead of digesting them, enjoyed the things that they were making so much that it didn't break them down like the food like it was planning to, and instead just kind of allowed them to live inside of them. Remember, symbiosis means living closely together, and endo means inside. So what you actually have here from the name are these bacterial cells that start living inside of your eukaryotic cells. One species lives inside another host species. The definition of endosymbiosis. We believe that mitochondria and chloroplasts have evolved from free-living prokaryotes that existed around the same time as this original eukaryote. Endosymbiosis benefited both organisms. By having this mitochondria-like prokaryote inside of it, your eukaryotes were much better able to get ATP that they needed for cellular processes out of a single sugar molecule. Remember, cellular respiration gives you about 32 ATP, whereas without that long, complicated process, cells typically get about 2 ATP per sugar, which is not that sustainable, especially when we're going to be big and complicated like these eukaryotic cells tended to be. On the other hand, the prokaryote, the mitochondria ancestor, got an easy supply of food because food was constantly being given to it and didn't have to worry about being eaten and digested by other things. So, you know, win-win for some definition of win. Eventually, it got to the point that neither of these cells could survive without one another. And so we say that they became inseparable and act as one unit. Yeah, if you take all this mitochondria out of a eukaryotic cell, not only do you watch the eukaryotic cell die, you watch every single one of those mitochondria die because they can't function without one another. We believe that chloroplasts were engulfed later by some ancestor of this first eukaryotic cell that engulfed in mitochondria because, well, every eukaryotic cell has mitochondria, but only some of them have chloroplasts. So it makes sense that you had these ones that were going around with mitochondria and living their best lives, doing whatever it was that they needed to do. And one of them engulfed a photosynthetic prokaryote, and all of its descendants went on to become your modern day photosynthesizers. But, ladies and gentlemen, as far as the notes go, that's it for the notes. The recommended reading for tonight is chapter 8.7. Please take the opportunity to do that reading. If you don't, please try to look over the teacher notes. It'll guide you through the way that I intended to when I'm not able to be there physically. If you have any questions, please log on to the Zoom chat or Zoom call. That is, the link will be posted. And please make sure to take the chapter 8.6 quiz on mastering biology. If you don't have any other questions, that'll be it for today. I hope you have a fantastic day, and I look forward to seeing you guys soon. Goodbye.